In this video, we're going to answer how are coterminal angles used to solve problems. So recall from the reading that coterminal angles have the same initial side and same terminal side, but they differ in rotation. Also recall that one rotation equals 360 degrees. Alright, let's take a look at this example. Find the angles of least possible positive measure coterminal with each angle. So let's start with A. I have 1,106 degrees. Well, I like to sketch this. So let's take a look. I'm going in the positive direction. That means I'm going to be measuring counterclockwise. So one rotation is 360 degrees. Another rotation is 720 degrees. A third rotation gives me 1,080 degrees. So I still haven't quite reached my 1106, but if I take 1106 minus 1,080, that is 26. So I need to go 26 more degrees. This 26 degrees here is what I'm looking for. So the angle of least possible positive measure coterminal with 1,106 is 26 degrees. Let me just write this out for us though. Let's take a look. Coterminal angles. So coterminal angles, let's just list what these are, the ones that are in the diagram. So first I have 26, right? 26 degrees, that's the smallest. The next one would be 360 plus 26. That one is 386. The next one would be two rotations. So two rotations is 720 plus 26. That would be 1106, which is what we started with. So I could keep adding these multiples of 360 forever, and I would come up with more and more coterminal angles. So a quicker way for me to come to this 26 degrees is simply to take what I started with, 1,106 degrees, and let me just subtract multiples of 360. So I would want to subtract, in this case we know we need 3 times 360, and that gives me my 26 degrees. So we just need to subtract the correct multiple of 360 to find the angle I'm looking for. Alright, let's look at the next one. Negative 150. So negative 150, instead of going counterclockwise, I need to go clockwise. Starting at 0, I'm going to pass negative 90, and over here is where negative 150 lies. Let's see, that's in quadrant 3. So what angle am I looking for here? I'm really looking for this angle. That's going to be the least possible positive measure. That's the angle I want. So how do I find it? Well, I know the whole way around is 360. If I subtract off that 150, then that's going to give me the angle in red. So 360 minus 150 is 210. And that's the answer. Okay, so this next one is negative 603 degrees. So that's more than negative 360. Let me just get myself a little sketch going on here. So if I go negative 360, I know I need 117 more degrees to get over here where I need to be, because I know that 360 plus 117 equals 603. So that's what I was looking for. 360 plus 117 is 603. But that's not the angle I need to answer this question. I really need this angle. So I know, however, from here to here, that was 117. So to get the angle I want, I just have to take 360 minus 117. 243. That's the angle of least possible positive measure, coterminal, with negative 603 degrees. All right, let's take a look at an application. A wheel makes 270 revolutions per minute. Through how many degrees will a point on the edge of the wheel move in 5 seconds? So 270 revolutions, that's like going around like this 270 times. That's a lot. Okay, let's see. I have 270 revolutions per minute. I can always write, when I see the word per, I want to write that as a fraction right away. So I have 270 revolutions per 1 minute. All right, now let me read the rest of the problem. Through how many degrees will a point on the edge of the wheel move in 5 seconds? So what other units do I need here? Let's see. I'm starting off in minutes and I want to end up in seconds. So I know that 1 minute equals 60 seconds. I also know that 1 revolution equals 360 degrees. So one thing that's really nice about these conversions, when you know things are equal to each other, is I can write them as a fraction. So know that 1 minute, and like if I take 1 minute divided by 60 seconds, that just equals 1. It just equals 1. I could also write that as 60 seconds over 1 minute. That still equals 1, right? That's why it's called a unit fraction. And then 1 in math has this special property where we can multiply anything we want by the number 1, and you just get the thing back. So if I take this 270 revolutions per minute and I multiply it by 1, but not just any 1, I'm going to multiply it by this 1 up here. That will get rid of, that will convert it. I want to convert my revolutions into degrees. So let me multiply it by the unit fraction. 360 degrees and 1 revolution. Right, that equals 1. So let's see, when I multiply these together, I'll be able to cross out my revolutions and I'll have an answer that will be in degrees per minute. But I don't want it in degrees per minute, I need degrees per second. So let me use 1 minute to 60 seconds. Now when I multiply these all through, I see that my minutes will divide out, and I'll be left with an answer in degrees per second. Perhaps you recall this from chemistry. This is called dimensional analysis in chemistry. Alright, so I'll multiply all my numbers together to get 1620. So that's going to be 1620 degrees per second. Alright, so I know that a point on the edge of the wheel, so my point is just on the edge of the wheel and it's traveling around. In 1 second, it will travel 1,620 degrees. But I don't want 1 second. I want 5 seconds. So just multiply this by 5. Alright, that means my point is going to go 8,100 degrees in 5 seconds. Alright, so here's the suggested textbook problems on the bottom of page 6. Good luck!